Hi, and welcome to this video on annuities. An annuity is a series of payments, usually in equal amounts, made at regular intervals for a fixed period of time. For example, we have the following problem that involves annuities. While buying a new car, Rebecca made a down payment of $800 and agreed to make month-end payments of $270 for the next 4 years and 6 months. If they were charged an interest rate of 4% compounded quarterly for the entire term, answer the following rounding to the nearest cent. First, what was the cost of the car when Rebecca purchased it? And second, what was the total amount of interest paid over the term? To work with a problem like this one, we need to identify various variables. And here we have a down payment of $800. That's important. And we have regular payments of $270. That's the amount of the periodic payment. So PMT equals 270. And those payments are made for 4 years and 6 months. Because those payments are made on a monthly basis, we have that the number of payments during the term of the annuity is going to be, so every month for 4 years and 6 months would be 4 times 12, because there are 12 months in 1 year, plus 6. So we have the number 48 plus 6, and that's 54. So the total number of payments during the term of the annuity is 54. Now here in this problem, the nominal interest rate is 4%, and it's compounded quarterly, so M is equal to 4. So we can say that the periodic interest rate is given by J divided by M, and that's 4% divided by 4, that's 1%, or same thing, 0.01 in decimal form. Now, we have that Rebecca agreed to make monthly payments, and interest is compounded quarterly. Then what we have here is that the compounding period is not the same as the payment period. The payment period is 1 month, but the compounding period is 3 months, because interest is compounded quarterly. So the annuity we're presented with here is an ordinary general annuity. So let's write that here, that we have an ordinary general annuity. And because we have an ordinary general annuity, we need to find the equivalent periodic rate that matches the payment period. Then using that equivalent periodic rate, we can use the ordinary simple annuity formula to calculate the future value and present value of the annuity. Now, the equivalent periodic rate, interest rate per payment period is given by 1 plus I to the C minus 1, where C is the number of compounding periods per payment period. Now we have the number of compounding periods per year, that's 4, divided by the number of payments per year, that's 12. So what we have is that I2 is 1 plus 0.01 to the 4 over 12, take away 1. That's what we have in this problem. And when we compute this value, we find the number 0.003322 and some other digits. Okay. Now, let's work on part A of this problem. We want to know the cost of the car when Rebecca purchased it. That means the present value of Rebecca's car. The present value of Rebecca's car can be found by using the ordinary simple annuity formula with the new periodic interest rate. So we have PMT times 1 minus 1 plus I2 to the negative n divided by I2. So in our case, we have the present value of Rebecca's car, that's without counting the down payment yet, is 270 multiplied by 1 minus about 1 plus about 0.003322 of this to the minus, and n is given by 54, so minus 54, and then this gets divided by 0.003322, etc. And when we use a calculator to compute this value, we find the number 13,326.774975 and more digits. So the cost of the car when Rebecca purchased it was the value we just found, 13,326.774975, etc., plus $800, the down payment. And then when we add those two numbers up, we get approximately $14,126.77. Okay. Now to work with part B of this problem, we want to use another formula. The amount of interest paid equals the, so in this case we have the equals right here, the amount that Rebecca paid for the car without taking the value of money, the time value of money into account. So there is like 54 times $270 plus 800 minus the cost of the car. So that's 14,126.77. This is approximately equal to. And when we perform this subtraction, we find $1,253.23. So that's the total amount of interest paid over the term. Rebecca paid a total interest of $1,253.23 for the car. All right, so that's the end of this problem. Remember that we're working with an ordinary general annuity because payments are made at the end of a term. That makes the annuity ordinary. But the compounded period is not equal to the payment period. So we need to find the equivalent periodic rate. And then we use formulas that apply when we have ordinary simple annuities to find a solution to part A of this problem. And then for part B, we just subtract a couple of values. Right? If you have questions, please write a comment or contact me and I'll be happy to help. Bye.